Okay, good day class. Alright, so last video we have discussed what is Maclaurin theorem. Alright, so it starts from a power series. Then from the power series you have Taylor's series. Alright, then from the Taylor series you get this Maclaurin series. Alright, and we also have learned how to use Maclaurin's theorem. Alright, follow step by step and to get the Maclaurin series of a function. Alright, so I hope that you understand well about the theory, and don't forget, alright, so in general the Maclaurin series can only be determined if all these three criteria must be fulfilled. First, the nth derivative of fx exists, means we can derive or we can differentiate a function for many levels. Alright, second, fn 0 is defined, means when you sub 0 x equals 0 into any level of the derivative function, is defined, you can find the answer. And the last one is the series obtained converts to fx. Alright, these three criteria must be fulfilled, so memorize it. Alright, so today we are going to see what are the actual steps that we have to use by using Maclaurin's theorem to find the Maclaurin series of a function. Alright, so before we go to the steps, let's see about some standard Maclaurin series. Alright, standard means it is general and it is given in the exam. Okay, so we can use Maclaurin's theorem to find the series expansion of some standard functions such as exponential function ex. Alright, this one. Logarithmic function like ln 1 plus x. Okay, trigonometry functions like sine x, cot x, even arctangent x, and some others algebraic function like 1 over 1 plus x. Okay, so we can use Maclaurin's theorem to find all these series of expansion. Alright, so below are some common functions and their Maclaurin series. Okay, so you can see, okay, a function ex can be become a Maclaurin series in this way. So means ex is actually approximate to 1 plus x squared over factorial 2 plus x cubed over 3 factorial 3 plus dot dot dot. Alright, and the sigma notation is this one. From all this we get this sigma notation. Okay, it's very clear that you see the power for x is increasing from 0, 1, 2 to 3. So it's n, so n start from 0 to infinity. Okay, and the coefficient is 1 over 1, 1 over factorial 2, 1 over factorial 3. So it becomes 1 over factorial n. Okay, and the interval of convergence. Remember, interval of convergence means that what are the values of x that we can sub in so that we can find the approximate value of ex. So for this function, the interval of convergence is all real number. Okay, means any value of x you can sub in. Then by using this approximate value, by using this Maclaurin series, you can find the approximate value of ex. Alright, so this is one of the example. Okay, the second one is ln 1 plus x. Later we are going to discuss this. Then you can fill up this table. Okay, this is for sine x. So you see that the power for x is all the odd number 1, 3, 5, 7. Okay, and the denominator just follow. If 1, then factorial 1, 3 factorial 3, 5 factorial 5, and so on. Alright, so you can see how we can get this Maclaurin series for sine x in page 156. Alright, example number 2, page 156. You can go through yourself. Alright, and the interval of convergence also all real number. Later we are going to discuss cos x. Okay, so you see the difference. For sine x, the power of x stuff all the odd number 1, 3, 5, 7, right? And then for cos x, the power of x is all the even number. Start from 0. So this is x power 0. So 2, 4, 6, and so on. And the denominator same. Follow the power. If x squared, then factorial 2. X power 4, factorial 4. X power 6, factorial 6, and so on. But, so sorry, I forgot. For sine and cos both, their sign are alternate, you see? Negative, positive, negative, positive. So for cos also the same. Alright? So these are the sigma notation, and these are the interval of convergence. Okay, this is for arctangent. Even arctangent also can. Okay, and 1 over 1 minus x, algebraic function. This is the expansion. And 1 plus x to the power of n, this binomial expansion. So in Sem 1, you have learned how to expand this by using binomial theorem. Okay, so later we will see how we can use Maclaurin series to expand this one also. Alright, so you see that actually in STPM, so in STPM, there are some general Maclaurin series given to you. So you can see. So all these 4 you don't have to memorize. So other than that, it's worth for you to memorize some. Alright, so the Maclaurin series given to you in the exam is Maclaurin series for the function ex, ln 1 plus x, sin x, and cos x. Alright, only these 4 given to you. Okay? Alright, so now let's see how we can use Maclaurin's theorem to find the Maclaurin series. Alright? So example 5121, the first question is show the above Maclaurin series. Alright, so just now in the tables, you are given 7, include these 2, 7 Maclaurin series. So I'm going to discuss a few, so the rest you have to do it. Okay? Alright, let's see the first one, ex. Okay, how we are going to use Maclaurin series to find ex. How we are going to use Maclaurin's theorem to find the Maclaurin series of the function ex. Alright, so first remember this. This is a formula. Alright, f0, f prime 0x, f prime prime 0 factorial 2x squared, f prime prime 0 factorial 3x cubed, and so on. Alright, this is the theorem, Maclaurin's theorem. Alright, so since this formula is given, so definitely you know that by using the Maclaurin's theorem, you need to find all the values for f0, f prime 0, f prime prime 0, and so on. Alright? Okay, let's see the first function, ex. We always let the function given to us as fx. So fx is ex. So first I find f0. I sub 0 into the function. So e power 0 is 1. Then I differentiate fx. So differentiate ex, you get ex. So your f prime x is ex. So again, sub 0 in your f prime x, also 1. This is very easy for this one, because the second derivative, third derivative, fourth derivative, all are ex, because you know that every time differentiate ex, you get ex. Alright, and when you sub in 0 to all these derivative, you get all the coefficient are actually 1. Alright, so once you have get all this value, alright, then we sub into the Maclaurin's theorem. Alright, so the function ex is equals to, if possible, please every time copy, okay, copy all this, copy this Maclaurin's theorem. Alright, copy it. Then only we sub in the value. It will make you less chances to make careless mistake. Okay, one question, maybe you will ask, teacher, then how I know when I'm going to stop? Because you know that actually Maclaurin series, most of them are infinite series. Okay, so very simple. Normally, if the question never mention anything, we will show at least the first 4 non-zero terms. Okay, at least. If the question mentioned, then we just follow the question. Alright, later when we discuss STPM question, then you will see. Okay, so I copy the Maclaurin's theorem, then I submit. So just now I already calculate f0 is 1, so 1. Alright, sorry, so f prime 0 also 1. Okay, so 1x. F prime prime 0 also 1, so 1 over factorial 2. Factorial 2 is 2 x squared. Alright, f prime prime 0 is 1 also, factorial 3, so factorial 3 is 6. Alright, and the fourth derivative is 1 also, so 1 over factorial 4. Factorial 4 is 24. Alright, so this is already the simplest way. Then don't forget, remember, don't ever forget your plus ... Okay, this one must have, just like the first time. When you learn series, right, always have to remember to put the plus ... Okay, and in just now I already say the interval of convergency. So we know that actually function exx can take any value. Therefore, the interval of convergency is from negative infinity to positive infinity. All right. So, sorry, this is the first standard one. Okay, let's look at the second one. Okay, now we are going to discuss logarithmic. All right. Logarithmic. Okay, the second one. Let fx equals ln, excuse me, sorry. Let fx equals ln 1 plus x. So I sub 0 in. So ln 1 is 0. All right. Then second, differentiate ln. So remember, differentiate ln is 1 over. So ln fx, differentiate ln fx is 1 over fx, multiply f prime x. But when you differentiate 1 plus x is 1. Okay, so this is a f prime x. After I get my f prime x, immediately I sub 0 into my f prime x. Oh, always do like this. So when you sub 0 here, so the f prime 0 is 1. All right. Okay, and so on. So you see here. Factorize this one. So this is actually 1 plus x power negative 1, right? So when you differentiate this one, simple. Index in front, so negative 1. Index minus 1, so negative 2. Like this. Okay? Then immediately I sub 0 in. So the f prime prime 0 is negative 1. Okay, third derivative, same. This is actually negative 1 plus x and power negative 2. So when you differentiate index in front, so negative 2 in front multiplied with negative 1, so positive 2. Index minus 1, so cube lah. Alright, then immediately sub 0 in here. Okay, so the answer is 2. F prime prime 0 is 2. Then next, again, differentiate. So we are actually doing differentiation. Alright. So just now it's 2, right? So the power is negative 3 ma. So index in front. So negative 3 times 2, negative 6. So index minus 1 again. Alright, so immediately sub 0 in. So your answer is negative 6. Okay, so as I say lah, we show at least first 4 terms, 4 to 5 lah. Okay, by right, first 4 term is 1, 2, 3, 4. But why I do one more? Because the first term 0, you see. So I have to show more lah. Alright. Therefore, next step. Yes. Write down the Maclaurin's theorem. Therefore, ln 1 plus x is this one. So this is the Maclaurin's theorem. After that, sub all the values in. Okay, remember one very important thing. Yeah, even though f0 is 0, please write it. The next step, when you sub all the values into your Maclaurin's theorem, please, even though it is 0, show it. Don't skip it. Alright, so remember this, very important. Alright, so f0 is 0. F prime 0, 1. So 1, x. F prime prime 0 is negative 1. So negative 1 factorial 2, x squared. Alright, f prime prime 0 is 2. Okay, 2 over factorial 3. So factorial 3 is 6. So x cubed. Alright, and the fourth derivative is negative 6. So negative 6 factorial 4 is 24. X power 4 and plus dot dot dot. Then we simplify. Okay, so the last step, we simplify everything. Now the last step, then you can skip your 0. Then only you skip your 0. Okay, remember this. So x minus half x squared. This one simplified, plus 1 over 3x cubed. This one simplified, negative 1 over 4x power 4, and so on. Alright, so if you want to write out the general term, very simple. Okay, you see that the sign is alternate, right? Positive, negative, positive, negative. So remember, we have learned this one in Sem 1. If the sign is alternate, then it's definitely is negative 1 to the power of something. And we know that this one starts from 1. X power 1, right? So 1 plus 1, 2. So square. Negative 1 square become positive. Alright, and the x is power r. Same like your r. When your r is 1, then this is 1, 1. When r is 2, 2 plus 1, 3, right? So negative 1 to the power of 3 is negative. All right. 1 over r, so 1 over 2. R is 2 ma, then x squared. This is the general term lah. If you think you want to write, if the question asks. All right. And of course, just now in the table, we already showed this one, right? So I just explained to you how we get this general term. So other question you can see yourself. Okay. And the interval of convergency. So we know that it's something, some sort like the geometry series, right? So the modulus for x must be less than 1. So x is sliced between negative 1 and 1. So why this one I put can be equal to positive 1? Because if positive 1 cannot, 1 plus 1 is 2 ma, ln 2 lah, right? If negative 1 cannot lah, 1 minus 1 is 0 what? And you know that ln 0 is undefined. Okay, so this is the second examples. How we use the Maclaurin's theorem to find the Maclaurin series of this function. All right. Okay, so next, the third example that I'm going to discuss is the function for cos x. Not difficult lah, cos x also. Alright, so this is for cos x. Alright, fx is cos x. So sub 0 into the function. So cos 0 is 1. Then differentiate cos x, we have negative sine x. So sub 0 into sine x, 0. Differentiate sine x is cos x, but we have a negative in front. So become negative cos x. So sub 0 in, become negative 1. Okay? Then differentiate cos, I get negative sine. So, but I have negative in front. So negative sine, positive sine. Okay, again, sub 0, you get 0. Alright? Then we see like repeat. When differentiate sine, I get back my cos. Okay? Sub 0 into the cos x, I get 1. Alright? So I stop at the fourth derivative. I stop at fourth derivative. Okay, but one thing is, you see, when you get certain derivative, the value of certain derivative equals to 0. So you know that when we sub into the binomial theorem, means some terms are become 0. If this happen, then you know that you have to show more derivative. So you see this one, I see this one 0, 0, 0. So when I sub in, I only have 3 terms. Only 3 derivative, not 0. So means I will only have 3 terms. Alright? If the question asks for more, so you know that you have to do more derivative. Okay? So again, write the Maclaurin's theorem, then sub in all the value. So f0 is 1. Just now as I said, f prime 0 is 0, right? So please don't skip. Don't skip. Write down. F prime 0 is 0, x. Alright? So f prime prime is negative 1. F prime prime prime, 0 again. So right, just sub 0 in. Write everything. Okay? Don't skip. Okay? And the last one is 1. 1 over factorial 4. It's actually factorial 4 lah. Okay, then we add one more step to simplify everything. So 1, so minus half square, plus, this one also 0, right? So plus 1, 4 factorial is 24. So 1 over 24 x power 4, and so on. Alright? So we know that the function for cos x is actually continuous, right? It's a continuous function. Therefore, x can take any values. Alright? This is for cos x. And as I said just now, how to get the Maclaurin series for sine x, so you can refer to your textbook. Alright? You can refer to your textbook. It's actually shown in your textbook. Okay? Page 156. Here. Okay? Page 156. Alright? Example 2. This is how you use Maclaurin's theorem to find the expansion for sine x. Alright, you can refer here. Okay, so this is for cos x. Alright. Okay, next. So next I'm going to discuss arctangent. Alright, you see, arctangent is actually more complicated. Alright, it's actually more complicated, but doesn't matter, we go step by step. Alright, so fx, your function is arctangent x. So we are going to find the Maclaurin series for this function, alright? So first, I sub 0 in. Oh, don't shake. Okay. Okay, I sub 0 in. So arctangent 0 is 0 lah. Okay? Then I differentiate. Alright? So differentiation for arctangent, arccos, and arcsine. Remember, it is given in your formula list. When we learn second chapter differentiation, so you know already. For chapter 2 differentiation, yes, the answer for this 3 given. Differentiate sine x, differentiate arcsine, differentiate arccos, and differentiate arctangent. So we just refer to the formula list. So differentiate arctangent is 1 over 1 plus x squared. Alright, so just copy from here only. Alright. Alright. So the first derivative is 1 over 1 plus x squared. Alright. Then sub 0 in. So your f prime 0 is 1. Okay. So this one, I can write as 1 plus x squared power negative 1, right? Easier for me to differentiate lah. Okay. So second derivative will be index in front, index minus 1. So don't forget to multiply, differentiate inside. So differentiate inside is 2x. Alright. So we rearrange in a proper way. So it's minus 2x, 1 plus x squared and square. Alright. Then sub 0 in. So when you sub 0, you know that it is 0 lah. So again, you see, first term as third one disappeared already. So you only, so far, only one term only. Alright, so means that we have to do more. Okay? Then the third derivative. Alright, for the third derivative, we know that we have to use quotient rule. UV, remember? UV. We use quotient rule. Alright, so V du dx. So differentiate negative 2x, you get negative 2. Minus U dv dx. So differentiate this one, index in front, index minus 1, multiply inside. Differentiate inside. Okay? Then V square. Alright, so I will rearrange first. So in front here is negative 2, 1 plus x squared square. Alright, here is 2x times 2 times negative 2x, negative, positive. So altogether 8x squared. And 1 plus x squared. Alright, after that I simplified. I simplified 1. So 4 become 3. I simplified here 1. Alright, so simplify again. So this is minus 2, minus 2x squared. So minus 2x squared plus 8x squared is 6x squared, then minus 2. So simplify first. Alright, then at the side, you sub 0 in. So when you sub 0, it's negative 2. This one is 1. So negative 2 over 1 is negative 2. Okay? So now, next. Yeah, we have many derivatives to see lah, to go on. Okay? You see the next one is, okay, let's move it here. So can see. Alright. Okay. Alright. Can see it? Okay. Alright. So just now we got this one already, right? Okay. So again, use the product rule. Quotient rule. U, V. Alright. So V du dx. So differentiate here is 12x minus U dv dx. So differentiate here is 3 in front, copy, index minus 1, multiply, differentiate inside. So square. So just now is power 3 already. So after square is power 6. Okay, power 6 first. The red color later. Okay, so next step we try to simplify first. So you see I have 1 plus x squared, 1 plus x squared, 1 plus x squared. So we can simplify them. So the smallest is square. So means that we can simplify 2 square. So simplify 2 become power 4. This one simplify 2, so become 1. Alright? We simplify first. Then we rearrange it. So this one become 1 only. So 12x can multiply in. So 12x multiply 1, 12x. 12x multiply x squared, 12x cubed. Alright? So this part, this is 6x. Alright? So 6x multiply 6x squared, So 36 x cubed. Minus lah. Then 6x multiplied negative 2, 12x, negative 2, negative, positive 12x. Alright, this one left power 4 lah, the denominator. Okay, now left what? 12x cubed minus 36x cubed, so it's negative 24x cubed. 12x plus 12x, 24x. Alright, okay, then sub 0 in. So 0, 0. So fourth derivative is 0. Okay? Alright, I work up to the fifth one. Because you see this one 0, this one 0. So no, 2 terms only. So left 1 term, 2 terms. This one also 0. So as I say, minimum we must have at least 3 terms lah. So I need to work up until the fifth derivative. Okay? Or else left 2 terms only. Because the function itself, second derivative, fourth derivative, all are 0. Alright? So again, another quotient rule. So v du dx. So differentiate this one is 24 minus 72x squared minus u, copy your u, differentiate here. So 4 in front, index minus 1, multiplied inside. Okay, so simplify first. So you see I have x plus x squared and cube. I have 3 here, I have 4 here, and 8. So we simplified 3. This one cancel. So simplified 3 left, 5. So this one this is 4 simplified 3 left, 1. Okay? So because I'm not going to do another derivative, so I don't simplify it lah. I don't need to simplify like this. Because this one I have to simplify because I need to do another derivative. And then easier for us to sub in the value also lah. But now I'm not going to do the further derivative, so I just let it in this way. So very easy to see, you see. When you sub in 0, very simple. When you sub in 0, you see this one already becomes 0. Multiply, multiply, multiply 0. So this one totally 0 already. Okay? And this is 1 now. When sub in this one 0, denominator is 1. So we need to calculate here only. Okay? So this one 0, so become 1. This one 0, 24. So 1 times 24, 24. Alright? Okay. Now, next step. Therefore, arctangent x will be, so we copy down the Maclaurin's theorem up to x power 5 because we are doing up to fifth derivative. So your Maclaurin's theorem, you write up to x power 5. Alright, then sub in all the values. So f0 is 0, f prime 0, 1, f prime prime 0, 0. So please remember, write 0. Don't just skip. Okay, so f prime prime 0 is negative 2. Yeah, just on here. Negative 2 over 3 factorial 3. Factorial 3 is 6 lah, x cubed. Fourth derivative again 0. And fifth derivative 24. 24 over factorial 5. Factorial 5 is 120 lah. X power 4. Again, remember, don't forget your plus dot dot dot. Alright? So the last step, yeah, just simplify that. Alright? So you see, even though I do up to fifth derivative, but after simplify, I only have the first 3 terms. Okay? Alright. So maybe I make it smaller so that you can see the whole answer. Okay. Yeah. Like this. Okay, push it here a bit. Okay. So this is the whole answer for arctangent x. Okay? Alright, next. Alright, so the next question, I'm going to discuss one algebraic function. Alright, one algebraic one. Okay, maybe make it bigger, easier to see. Okay. Alright, this one. So fx is 1 over 1 minus x. So I write it in this way lah. Later easier to differentiate, okay? So straight away sub 0 in, so I get 1. Okay, differentiate. So index in front, index minus 1. Okay, multiply inside, differentiate inside is negative 1. Alright, so negative 1, so I have 1 over 1 minus x squared. Okay, again sub 0 in, I get 1. Alright, so second derivative, so this is actually 1 minus x power negative 2. So differentiate index in front, index minus 1. Okay, again, differentiate inside the bracket is negative 1. Alright, so negative 1, negative 2, positive 2. Or positive 2. Okay, positive 2. So sub 0 in, 1 now, so positive 2. So your second derivative f prime prime 0 is 2. Okay, then next differentiate this one again. So just now positive 2, right? Coefficient, just copy. So index in front, index minus 1. Again, multiply negative 1. Alright, so together is 6. Oh, I simplified this one here. This one I didn't simplify. Okay, want to simplify also can. This is 2, 1 minus x power negative 3. Okay, sub 0 in, your third derivative is 6. Alright, so since there is no 0, right, so I get the first 4 terms. So I stop here lah. Okay, so next step, very simple. Alright, very simple. Therefore, 1 over 1 minus x is, copy the Maclaurin's theorem until x cubed lah, because I do up to third derivative. So up to x cubed, sub in all the values and simplify them. You see that 1 over 1 minus x, this function, when written in Maclaurin series form, very simple, just 1 and then all plus, you see, the power for x just increase, coefficient all 1. 0, 1, 2, 3, very simple. It's a very easy Maclaurin series to memorize. Alright, then next is, as I said, you can see. Okay, alright, can see. From the first step until here. Alright, okay, next, binomial. Remember this binomial series? In Sem 1, you use binomial theorem to expand it. Now we use Maclaurin's theorem to expand it. Alright? So your fx is 1 plus x to the power of n. So again, sub 0 in. So 1. 1 to any power is still 1, right? So even though we don't know what is n, is okay. Okay, so the first derivative differentiate, very simple. Index in front. So index minus 1 become n minus 1. Multiply differentiate inside is positive 1, right? So I just don't write the positive. If you want to write also can. Okay? Then sub 0 in. Okay? So 1 to any power is still 1. So your f prime 0 is n. Okay. Second derivative. N is coefficient, just copy. So index in front. So index minus 1. So n minus 1 again, n minus 2. It's just like that. Alright, then sub 0 in, so this is 1, okay, 1 to the power of anything is still 1, so your f prime prime 0 is n minus 1, okay, then the third derivative, so n minus 1 is a coefficient, so we just copy, then index in front, again index minus 1, so sub 0 in, so 1 power n minus 3 is still 1, so your f prime 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 0 is this one, n minus 1, n minus 2. Here. See? You see? Okay, so after you got your f0, f prime 0, f prime prime 0, f prime 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 0 again. Alright? Therefore, your 1 plus x to the power of n, copy the Maclaurin's theorem, then sub all the values in. Okay, you can refer back your Sem 1 binomial series and you check. It's actually the same. Okay, so this is how we use Maclaurin's theorem to expand the binomial expansion. Alright? Okay, so the few standard series in your notes, I have explained all. I have explained all. Okay? only left sine x that you can refer to your textbook. Okay, all right, next we will see some question in exercise 5.1. Okay, page 159. Yeah, we are going to discuss a few questions here. Okay, exercise 5.1. Yeah. Okay, so just now question 1 all have discussed, no? Okay, now I'm going to discuss question 2. So using Maclaurin's theorem. So remember, when the question says using Maclaurin's theorem, you have to go through all the steps to find f0, f prime 0, f prime prime 0. Must. Okay? Obtain the expansion for each of the following functions. State the interval of convergency in each case. Alright? So the first one I'm going to discuss A. Okay? Sorry. Okay. Alright. A, e power negative 5x. Alright?